So hello everyone. Today I'm very happy to have a chance to give a presentation about some. It's more like a hobby project, but I'm because I personally I am a PL researcher. So the first thing I'm thinking about is as a programming language researcher, since the large language model area, and from time to time worried about my own career. So because the more and more code are written by language models, but for programming language, a programming is designed for someone to write code, right? But now more and more code are written by an agent, but still, so will this shift our interest as a programming language researcher? So this is a question I'm thinking about, like what are the differences since the large language model area for humans writing code? So one thing is that there's a new kind of software which is agent. I think most of you are familiar with this idea. There are lots of agents and also agent frameworks, lots of them. So we can also kind of have a more formal definition for agent is like this large language model integrated software. And as for now, at least for now, many of them are still programmed by humans. As for now. So maybe in the future, more and more agents are also coded by agents. But now we stick for the current status. Is still we humans have to implement like how you compose different language models to achieve a specific task. Then, so from the angle of software engineering, will this software pose different problems concerning like the correctness, efficiency, or modularity about this software? So there are kind of several work I found from the literature. For example, for the correctness, a recent study at ICSI reports there are many kind of integration defects which will affect the correctness of large language model integrated software. And for efficiency, like there will be a paper this year about how to automatically improve efficiency in terms of making more remote large language model calls like parallel, and you can stream all the calls. So efficiency is a problem. For modularity, currently I don't find any kind of paper about modularity yet, but I found this AIO's paper focused on the separation of concerns in terms of how to engineer the agents in terms of resource management from a system level. So yeah, so I think we can agree on that there do exist some concerns about their correctness, efficiency, and modularity. So, but how does it differ from the past software engineering? So what are the features for large language model integrated software? So they interact with large language models heavily, but like more concretely, if we can think in terms of correctness, efficiency, and modularity, what we identify or in this position paper is that for correctness, many of the defects come from the uncertain behavior of large language models because they may harm the robustness of your software, and also they may influence the reproducibility. And for efficiency, this course will take a long execution time, especially when you call a remote service. So this will require a software to schedule large language model calls wisely. And third, for modularity, so it's more about how to test and profile your agent. And because of this distributed execution nature, it's kind of hard to test and profile. So in this paper, we kind of have some preliminary thought, and this thought is based on the observation that the logic and the workflow of agents are usually not very complex. For example, many frameworks, so this figure comes from the long graph framework. They have identified many commonly used patterns for agents, and they can all summarize in one single figure, like the one shown on the slide. But then the complexity comes from actually the effects of these agents, and they make the engineering of agents complex. So including all this uncertain behavior, long execution time, and also the nature of distributed execution. So since the question comes from the effects of agents, so why don't we apply like effect handler oriented programming? So here I won't go into the full detail of what effect handler is, but here I only use a very restrictive form of effect handler, which can be implemented in Python. So it's a very limited form. So for example, when I see this workshop, I myself want to brainstorm how I can write something for this language model programming language workshop. I come up with this workflow. So maybe I want to get some research topics about how to apply programming language techniques for large language model applications. So you might have first you might write a very simple workflow. You first get some topics, then for each topic you ask the large language model to get a description for every topic. So even though this script is very simple, there are kind of several interesting features. First, the getTopics is a distributed call because it has to interact with your this LLM service. So so its result is uncertain. Then for this getDescription, it's another large language model call, and so it is also distributed, and it might take a very long execution time. So for this simple script, there's a very clear opportunity to optimize because you can easily think we can do every loop iteration in parallel because they don't have any data dependence. And the third effect, which is kind of like a standard effect, is basically the log effect. It's basically a standard input-output effect. So you can see, you can imagine if you want to kind of parallelize this script, and you want to also keep all the log operations like still operates in their sequential order, it will give you a lot of trouble. But still, like the key observation is that the logic itself is not very complex. It's basically you just call the large language model, then you do a simple loop. So the idea for effect handler-oriented program is to separate the logic and workflow from the actual implementation of these effectful operations. So what we want to kind of achieve is that once we have this research topic script, if we want to plug in some different context, we only need to change the outer context instead of the script itself. For example, we can wrap the research topics script with a stack of handlers, which I will explain later. This is for like a synchronous version. So this is very suitable for development and when you debug your own workflow. Once you have finalized your design, you want to have a more kind of a different stack of handlers, and this is for like an asynchronous version, which is suitable for deployment. And finally, when you want to kind of do some testing and profiling, you want to switch again to a third variant, and this is a mocking version. So basically, you kind of trace some language model code from a previous run, and then you replay the trace with the same logic and workflow. So the effect is that the workflow logic itself it will keep the same, and you will not alter the implementation of the research topic workflow. You only need to change the outer context or handlers. So how does effect handling achieve that? So basically, the basic idea is that here we just like as a proof of concept, we use Python's with clause to implement a very restricted form of effect handling. So here, every operation is basically a callable object, but it does not attach to any concrete semantics. So basically, operation just only provides the syntax. So their semantics is determined by the so-called handlers. So basically, you can think of these operations as a special form of exceptions. They raise an exception, and it will be called by a particular handler, and the handler gives the concrete semantics to these operations. And once again, you can define like your handlers. You can even forward the same operation again to some other handlers. So this will give you a very kind of powerful way to compose different handlers and to get a very kind of to kind of change the behavior of the same script, like in a very kind of seamless way. So as like as a practical use of composing operations, consider a set of asynchronous related operations. Here we have like async is basically you want to schedule some coroutine, and then you can have this await, which we want to wait for the completion of some future objects. And the third one is like basically you can, it's a simplified call to an LLM, which basically you want to perform a completion from a given prompt. So these three are all like operations. They might have different meaning under different contexts. Because, for example, for the deployment, these async calls are really try to connect to the remote service to ask for the language model to do completion. But for mocking version, they might just read from the response from a given trace. But here, if we just compose these operations, we can use them to define like this get topics and get description, these operations for our research topic running example. For example, you can use await and you can compose await and complete to implement the get topics. You can use complete to implement get description. And one tricky part is for the log, because even if this log it appears very simple, but because under like a parallel setting, we want to keep all of these I/O effects like as if they are in a sequential manner. So we kind of so you can wrap some kind of delicate like it's like a locking step or like some synchronous mechanism, but wrap them all in the implementation of the handler. So in this way, we can reuse different kind of effect handler and compose them differently to achieve different kind of effects. For example, the asynchronous versions basically we use this asynchronous handler and then the asynchronous large language model handler and also then our application handler. Then by substituting only like the second handler from a concrete large language model handler to a replay handler, we basically obtain from a deploy.
Okay, thank you, Dee. Yeah.
The example that you gave, which is this dev research topics, get topics. Basically, your work isn't really necessarily bound to LLMs, right? I mean, you could be basically, I mean, you're trying to put in this effect handlers. I mean, you're trying to parallelize what would otherwise be sequential code. So this example happens to be you're querying some kind of LLM server, but you could be querying any kind of a server, correct? Yes. So.
Here's another point that the efficiency is not the main point, but also kind of if you can optimize the efficiency in a modular way. And yeah, so basically we don't have anything particular to large language models.
Yes.
So
Yes.
It could be any remote service. Yeah.
Yes. Yes.
But one point is that because of these codes are highly uncertain, so maybe you can have more like error handling in the handler. So that might be related to language model, but yeah, I think your point is right. It's not tightly connected to language model.
Just one last one. May I make a suggestion? If you use the word compose too often, it sometimes becomes hard to understand because so many things compose in so many different ways. So in chapter 2, you talk about how you could have a log handler and then a log date handler, and how you could, in a sense, combine the two. Can I suggest that you use the word chain instead? Because here you are basically, so this log now, your logging handler, right, is, you have one chain to another, right? Because in the algebraic effects literature, what you actually have is you've got one piece of code using one effect, and then the other piece of code using a very different effect. And then you're basically you're wondering about, it's like, now I've got code that calls these two pieces of code, and it is with algebraic effects, as opposed to monads, where you can get this composition, in a sense, for free. That composition is solved problem. But here it's really, you're chaining the logging, isn't it? And for instance, if you switch with log handlers, like if you put log date handler first, it will be a runtime error. Why would that be a runtime error?
Because like if you switch the order, this log operation will first be sent to the log handler. Sorry, it will not be a runtime error, but it will only print the log, but not the date. Because the log handler will not forward the log operation. So
but it looks completely identical. Why wouldn't it?
here, this log date handler will kind of forward
Oh.
operation out.
Oh, okay, but you don't have it over there. I see. Okay. So there's the chaining, the thing, right?
Okay, the last one question. Okay.
Yes, for sure. Very short one and last one. So did I understand correctly that the efficiency optimization was just because that's all the requests to LM, they got asynchronous instead of being sequential? That's all, yes? So basically, if in the very first example, you would write this code to use asyncs in the first place, then it would be the same efficiency compared to the one like using your contexts.
Yes and no. Yes and no, but yes, it's a yes, because you can certainly rewrite the code using like the parallel programming or like asynchronous programming. But then, if you want to keep all the kind of the for loop for these log operations still perform in a sequential manner, you can think of you need to do some kind of delicate programming because you will first maybe make a parallel for, right? So you perform all the tasks, obtain all the results, then do all the logging in the order. So it's kind of delicate, but yeah, you can do that.
Okay, thank you very much.